Hi, I'm Guanhong from Academy of Arts and Design, the Future Lab, Xianghua University, and I'm happy to report on this work on behalf of my team. The fluid fiber is a material that floats flowing in a tube. Here is the fluid fiber, and it has been used in fiber art creation for many years. Here are some example art creations, and recently, the fluid fiber has attracted attention from each cell field. From the video, we can see that this material has many attractive characters. On the one hand, the fluid fiber allows it to be freely arranged or weaved to form displays with various shapes and structures. On the other hand, the liquid flow brings new expressivity and dynamics in various dimensions, including color, flow rate, and so on, making it suitable to express digital information in physical forms. As such, it presents as an attractive material to flexibly and dynamically show digital data in the form of physical or ambient displays to suit different contexts. However, although fluid fiber has been commonly used to make creative artworks, there is still very little knowledge about this material, limited to some artworks and this research called tool. This is the visual display of tool. We can say that tool focuses on researching algorithms to precisely control the position of the droplets in the tube, so that the droplets can form representational information like letters and numbers. Therefore, more broadly, questions about the characters of the fluid fiber material, the new creative possibilities fluid fiber can offer, the themes that fluid fiber can suitably express, and the possibilities it can bring to each cell design are still unanswered. At the same time, as more physical materials that enhanced with digital technologies are employed in each cell for innovative design, many each cell studies have emphasized the importance of understanding and sharing knowledge of these materials in design, such as their properties, limits, and possibilities. So we think fluid fiber is worth to understand, and in this paper, we aim to answer these questions. From previous design research, we found that fluid fiber materials, in particular, can be understood when craftsmen interact with them physically, spending time talking with the materials to explore different forms of creation. Therefore, to explore different forms of creation, as with other fiber materials, fluid fiber also has to be explored and understood by craftsmen through hands-on manipulation before it can be transformed into a piece of art. Hence, in this paper, we present a study based on a design workshop, where art and design practitioners who have experience in fiber art creation engage with fluid fiber in creation practices. We foresee that their creativity, sensitivity, and experience with fibers would help us uncover broad potentials of the material for expressive display. After considering feasibility and availability, we selected highly transparent TPU hoses that can be woven and are less prone to liquid blockades as the material for our fluid fiber. For flow control, we developed a toolkit that includes hardware components for generating bubbles and droplets, and a GUI design tool for arranging fluid layout, such as order, color, length, etc. This toolkit can help users with non-technical backgrounds independently complete the design of flowing effects. This video is the overall usage of the toolkit. It includes 3 simple steps. Towards the end of the workshop, participants came back with a variety of works. Let's enjoy part of their work together. Based on the works they produced, as well as semi-structured interviews with the participants, the study reveals rich data about fluid fibers' affordance as a media for expressive display. There are structural affordance as well as expressive affordance. In this paper, we draw Norman's notion of affordance, which is referred to as the perceived and actual properties of the thing, primarily those fundamental properties that determines just how the thing could possibly be used. Generally speaking, the structural affordance includes large and full arc formation, high friction of outer wall, high resilience, and employ other materials to support the structure. The expressive affordance includes life, emotion and mood, flowing substance, modernity, and music. These affordances help us uncover the unique value of fluidity for expressing certain information. Distinct from Tu's work, which is more engineering-oriented, Tu focuses on manipulating the fluid as discrete pixels on the screen, aiming to display representative information through precise control of its position. Our study focuses on the expressivity of fluid fiber in conveying information. Particularly, it highlights the unique value of fluidity as an intuitive form to express themes such as life, mood, love, music, change, and movement. Information related to the feelings, such as emotion, mood, love, vitality, and music, is by nature nuanced, layered, and varying. These qualities can be aptly captured by fluidity. As fluid fiber can give vitality and emotion to the art piece or information display, despite being composed of lifeless industrial tubes. For design potentials, fluid fiber could be used as dynamic skin for art furniture or ambient display with various structures. For example, in music visualization, we can apply fluid fiber to the aesthetic design of a speaker, such that the appearance of the speaker varies with the flow of fluid according to changes in the music. In addition, using our toolkits for independent creation also allows us to see the potential for DIY these customized products in the personal fabrication field. Finally, I conclude with the contribution of this paper. Firstly, we revealed the affordance of the fluid fiber as a flexible media for expressive display. Second, we collected 20 pieces of creative works for inspiring future creators. Finally, we presented a toolkit for designing fluid layout and controlling fluid flow. This is our work. Thanks for watching.